What you're about to hear is a series of pictures. For those who were here yesterday, you've seen some already, from our scientists working across the various domains: land, aerospace, maritime, cyber and weapons. And they're going to give you a 1-minute pitch on what they're working on. These are technologies that are currently in development or are on the cusp of transfer to capability. And as they give their pitches, they're really an opportunity for you, our partners in industry and academia, to engage with us and to work with us to advance these capabilities into the hands of the warfighter. So I'll just ask if we hold our applause till the end of all the pitches. There will be 10. I've got that right today. I won't be standing up halfway through the pitches. So, Tim, you want to come on?
Imagine a scenario where you've got a vehicle that breaks down. To return that vehicle back to service, you might need to find some spare parts to fix it. But what if you're in the battlefield or on the back of a ship? With limited spare parts, that vehicle may well stay out of action. Now imagine being able to make spare parts wherever you may be. Spare parts made on demand, anytime, any place. My name's Tim Harrison, and we in Aerospace Division can do this using additive manufacturing. But before we can fully utilise this technology, we need to show Defence that any part we make is fit for purpose and thus safe to use. We have a process and a plan in place to be able to certify parts as we make them in real time, but we need your help. We're seeking industry and academic partners to help us develop the technologies required to bring to life the idea that instead of needing a warehouse full of spare parts, you just need one 3D printer. Thank you.
We have created a technology which makes Australian submarines quieter and stealthier, could greatly enhance military reconnaissance in the battlefield, and could even dramatically improve ultrasound medical imaging. We have developed acoustic metamaterials like this, which are precisely designed and engineered composite structures with the promise to break the performance limits associated with the conventional materials. Many scientists have been talking about the potentials of these materials, but struggle to make them, mainly due to their complex geometries and difficulty of their manufacture. We have shown that we can design and manufacture them or fabricate them. By 2025, it is estimated that metamaterial manufacturing will be a multi-billion-dollar market. So we are looking for an industry partner to help translate these prototypes and lab processes to products and devices and make them available to the same market. If you would like to find out more, come and have a chat with me or attend my workshop this afternoon. Thank you.
Defence invests a substantial amount of time and money on training its ADF personnel. Unfortunately, not all complete their training, sometimes due to personal or medical reasons, or suboptimal performance. We've developed the Energy Boost Bar to provide increased energy and nutrients to fuel performance during training and demanding activities. The bar contains 1,000 kilojoules of energy, resistant starch, a sustained source of energy, vitamin D and calcium for bone health, and a suite of B vitamins and vitamin E. We are looking for partners in commercial industry to further develop the bar and get it to commercialisation. We would also like Defence support to further evaluate the bar during arduous activities.
Hi, my name's Vin Dang. So how do we make decisions faster and better than our adversaries? Commanders require situational understanding in order to make appropriate decisions. Underpinning their understanding is the ability to make sense of the information available. With current technology, the bulk of this thinking occurs within the human mind. And as humans, we can only process about 5% of all this information. So Intelligent Automated Decision Superiority, or IADS as we call it, is a proposal to undertake game-changing research and development in automation across this functional stack. The outcome will be machines that can process more information faster than humans to support the commander in making faster and better decisions. To take this proposal forward, we're seeking partners with expertise in the areas of artificial intelligence, computer vision, and information fusion. If you would like to know more, please see the team at the National Security and ISRD stand.
Hi, I'm Andrew Donoghue. The success of military operations depends on many inputs, from equipment on one hand through to personnel and everything in between. For each of these areas, it's vital to learn where the deficiencies lie and also how those things can be improved. So one of the ways we do that in Joint Operations Analysis Division, I'll talk about very briefly. We've developed a web application to assess a wide range of mission-critical inputs, things such as hardware performance, tactics, logistics, and even training. It works by capturing the wisdom of experts in these areas and then mining their collective evidence, arguments and judgments to tell us where the greatest needs and opportunities for change and innovation lie. It's already been used successfully to inform requirements for our next generation of frigates, to shape the direction of anti-submarine warfare, and even to help Navy develop its strategic plans. You might recognise our keynote speaker in the photo there. So what are we going to do next? We're seeking support from industry and academia to mature our prototype into a robust analytical application which can be easily applied by all defence services to impact and improve their capabilities for future military operations.
I'm Helen Cartledge. Do you know how doctors assess mental patients? They use questionnaires. Through MRI head scan, all scientists have found 24 brain chemistry changes related to different mental conditions. This is a world first. Defense is particularly interested in better, earlier, and accurate diagnosis of post-traumatic stress disorder, PTSD. So, as you can see on the screen, PTSD brain, they have a focus 1 and 3 reduced, compared with the healthy brain on the top of the screen. So focus is a kind of body sugar, 8 essential body sugar we need to communicate between cells to cells. If successful, this tool could be installed on the worldwide MRI machines by 2020. Please contact us if you're interested in this research, or you just want to have a discussion if your brain needs chocolate.
Hello. I'm here to tell you about these new multi-use underwater test facility. DSD we're primarily using it for shock testing and qualification of platforms and equipment, including testing commercial and military off-the-shelf equipment. I invite you to also come and use this great facility. Examples may include testing explosive performance, hydrodynamic research, signature studies, UUV testing. You tell us. It's located east of Gambie in central Victoria. It consists of a body of water 150 metres wide and depths of water up to 50 metres. It has infrastructure such as a crane platform, walkways over the water, boat ramp and buildings for working in. It also has a clear water pool for high-speed underwater imaging. If you'd like to learn more, come and see me afterwards or come and see our 360-degree virtual tour at the Maritime Division stand. Thank you.
Yeah, Kevin Hong. all we know, UAV and small drones become an increasing threat, but there's a lack of countermeasures, particularly for those fully autonomous UAVs. So today, I would like to pitch a novel UAV defeat system based on the high-power radio frequency technology. UAV sensors and controllers are full of electronics. If we can use radio frequency energy to disable, disrupt, and damage UAV electronic system, and then that is the capability. So that's why if we can deploy a compact RF system on a tactical UAV and fly this to the target area, it becomes an integrated weapon system to defeat UAV and UAV swarm. Right now, we are working on the reduction of the system size, weight, and power, and we would like to collaborate with the defense industry and the universities to develop this capability in Australia.
Tony Scoleri, Electronic Warfare Operations. In recent times, missile technology has made incredible progress. Not only it's become more lethal, but there are many more ways of being attacked. And the time it took me to say these sentences is the time it takes for a pilot to be shot down. Only a few seconds. Whether it is in a one-to-one dogfight or whether a terrorist picks up a shoulder-launched missile and fires. Our objectives are to use the latest video processing techniques to detect incoming missiles as far away as possible and classify them more precisely so we can deploy better countermeasures and keep our pilots and platforms safe. We intend to combine infrared and laser technologies to perform high accuracy object recognition and classifications. We are looking for collaborators in the areas of deep learning, small target detection, fast tracking. I'm also giving a presentation in the mini theatre a bit later today. So if you are interested in those topics, please come and speak to me. Thank you.
Good morning. I'm Kate Rowe. The Australian Defence Force will need a wide range of capabilities to secure Australia into the future. Choosing the best balance of these capabilities, for example, choosing between investment in submarines or investment in cyber capability, is complex and challenging. It needs an understanding of the government's objectives for the ADF, as well as the budgetary resources and analysis of likely future scenarios. DST's strategic research investment in modelling complex warfighting will develop novel simulation techniques that can handle the interaction of the technological, geopolitical and cultural factors that are part of the future operating environment. Our goal is to equip defence planners to exercise rational decision-making in the face of extreme complexity. Key modelling expertise resides in Australian industry, and we want to work with you to revolutionise operations analysis to support design of the future force.
As I said, all those folk will be out in the marquee during the day, so a great opportunity to go and engage with them and talk to them more. But let's give them a round of applause and thank you for that.